This video was released in 2026 on the video platform called YouTube. 21 years ago, the website youtube.com went live on the internet. 35 years ago, the internet in its modern form appeared on computer screens. 78 years ago, the first transistor was assembled, laying the foundation for microchips and modern microelectronics as a whole. 114 years ago, scientific progress in solid-state physics led to the discovery of the p-n junction, the key principle behind the transistor. 242 years ago, the steam engine kicked off the Industrial Revolution, pushing society towards physical sciences and innovation. 581 years ago, the mechanized printing press was built, enabling the widespread distribution of scientific work and stimulating the growth of scientific thinking. 1,431 years ago, the number 0 and the modern decimal system were introduced, forming the base of the exact sciences. 2,533 years ago, democracy was born. Just wanted you to know this. 5,000 years ago, the wheel and writing were invented, bringing constant drive for social evolution. 10,000 years ago, agriculture emerged, and with it the need for wheel and writing. 35,000 years ago, humans painted their first caves, capturing the world around them for the first time. 200,000 years ago, mitochondrial Eve was born, the common maternal ancestor of every single living human today. 500,000 years ago, Homo sapiens emerged, the thinking man. 2.5 million years ago, Homo erectus came to be, the upright man. 7 million years ago, labor created man himself, as Engels famously said. Well, at least in the form of the Australopithecines. 16 million years ago, with the appearance of orangutans, apes became slightly more human than they used to be. 29 million years ago, the very first hominid ape came into existence. 66 million years ago, the dinosaurs went extinct, while primates didn't. 200 million years ago, the first mammals started secreting milk to feed their young. 400 million years ago, the first dad left for the airport ahead of time. 2 billion years ago, cells bundled up to form the first multicellular organisms. 4 billion years ago, a random cell noticed that it was more alive than it was dead. 11 billion years ago, the Milky Way was formed, and then it took that long for apes to evolve and name a chocolate bar after it. Finally, an unimaginably massive number of years ago, a little bit of ammunition mishandling resulted in the Big Bang, and then it all took off. What I wanted to say is, Dear Big Bang, thank you for making this video possible. Without you, none of this would exist. But just how long is your project going to last? Chances are you've heard a thing or two about the technological singularity. And even if the name Kurzweil rings a bell, watch this video to its end. I promise I have something that will leave you surprised. Because I am about to divide your life by 0. The personal computer machine in our homes became personal only quite recently. Back in the 70s, computer didn't mean a neat tower block wired up to an LED monitor. A computer weighed nearly 30 tons, occupied an apartment building's worth of floor space, and processed laughable 5,000 arithmetic operations per second. Most importantly, instead of semiconductors, they relied on vacuum tubes. Semiconductors? I've heard that one before. Yes. A few years ago, the world slammed into a massive semiconductor shortage crisis. They are a main component of a microprocessor chip which is responsible for the performance of literally all modern electronics. That was the moment the general public realized chips are in absolutely everything: computers, phones, servers, and even cars. We also learned that roughly half of all chips are manufactured in Taiwan.
我在北京。
A geopolitical fact that serves as a cornerstone of that country's national security. Speaking of security, they're also crucial components of drone and rocket manufacturing. This is a global political issue, meaning even in a tech breakdown like this, we can't completely distance ourselves from politics. Then again, maybe that's exactly what you're here for. Let me know what you think about covering more political topics in the comments. But this video isn't about some new hypersonic missile running on cutting-edge technology. All of this is a prelude to a mathematical chart. See, back in 1965, Gordon Moore, the co-founder of Intel, wrote an article containing what was basically a prophecy. Integrated circuits will lead to such wonders as home computers, automatic controls for automobiles, and personal portable communication equipment. The electronic wristwatch needs only a display to be feasible today. For something said 60 years ago, this is absolutely spot on. Same could be said for what was later dubbed as Moore's Law. He noticed that roughly every 2 years the number of transistors on an integrated circuit doubled. Now, to be fair, Moore wasn't trying to cement his name in history as a prophet. He was just trying to estimate how the industry would evolve over the next decade. Granted, Moore's Law is finally starting to fizzle out. By the 2020s, engineers hit a physics ceiling. There is simply no space left on a silicon wafer to keep doubling the transistor count. However, if you measure the growth of computational power rather than the raw number of transistors, Moore's Law is still holding up. But what is actually interesting about this graph is that it's not a straight line. It's a curve. You're looking at an exponential. How about a small brain teaser? Let's pick a topic. Everyone is fed up by all the wars and politics, so let's think of something new. Imagine the Ministry of Defense has ordered you to manufacture space-grade semiconductors. What do you mean, what for? To launch radio-controlled holiday fireworks. Obviously, what else would it be for? Let's assume we can manufacture exactly 2 chips every day. The math looks like this. Day 1 equals 2 chips. Day 2 equals 2 more, 4 total. Day 3 equals +2, 6 in total, and so on. This is pretty elementary. The supply growth is linear, and the volume is predictable. If the order requires 4,096 chips, how many days will it take? Exactly 2,048 days. Okay, now what happens if we cast a Gemini doubling charm on our manufacturing capacity? The output doubles every day and the sequence becomes 2, 4, 8, 16, 32. On day 10, we would manufacture 1,024 chips for a total of 2,048. When would we then complete the order? If you said, the very next day, day 11, congratulations, you get it. By day 12, we would manufacture another 4,096 chips and double our initial order, making as much in a day as all previous days combined. This is what that chart looks like. This acceleration causes the straight line to buckle and curve upward into an exponential, where every next step dwarfs the one before it. As a result, instead of taking 2,000 days, the task takes just 11. A classic case of exponential growth. And the same can be said about the history of computer processing power. As you can see, the shape of that global tech curve and our chip factory example are identical. Are you kidding me? Look at the vertical axis. It's not linear, it's logarithmic. The values don't step up evenly with a 1000 plus every time. They jump by orders of magnitude. 1000 is followed by 10,000, then 100,000, and so on. We can flatten our exponential into a perfectly straight line using this exact same scale. Because the vertical axis scales by powers, a straight line here actually represents explosive progression. Understanding this is vital because it explains exactly how scientists calculated the specific date humanity gets divided by 0. Let's lighten things up a bit. Here's an old-school meme from the web's early days. Let that sink in. Moore's law explains the intense acceleration of raw processing power. But what happens when we apply this logic to macro-level systems? For instance, to the mechanics of life itself. One of the first minds to tackle this was a Greek physicist named Theodore Modis. With a PhD in physics, he had every right to build complex models and manipulate big data sets. Modis tried to identify universal patterns across entirely different systems to forecast the future. From the outside, his core hypothesis sounds like madness. It boils down to this. To predict where we are going, we must isolate the most critical milestones of our past, using the Big Bang as the point of origin. And yes, the timeline at the start of this video is the exact historical turning points mapped out by Theodore Modis. Before Moore's law became widely known, Modis used this data to describe exponential acceleration within human evolution and technological progress. You just have to plot the timeline like this. The mainstream public first caught a glimpse of this perspective on life in 2003, when Modis published a paper mapping out 28 canonical milestones. They start right at the Big Bang and end at the birth of the Internet and the sequencing of human DNA. Another person who got deeply captivated by this idea is an American engineer, Ray Kurzweil. Kurzweil started his career in optical text recognition, went on to build commercial synthesizers played by bands like Duran Duran and Depeche Mode, and from that got into researching machine learning at Google. By the way, you can participate in some machine learning right now. If you hit the like button and drop a comment, you are actively training the YouTube algorithm to recommend this video to brand new viewers. Thank you. Kurzweil took Modis's data points and mapped them onto a chart that quickly went viral. As you can see, it mimics an exponent. Let's strip away the logarithmic scale from the x-axis and there it is, the vertical spike. Raymond looked at this mathematical cliff and concluded, "We are f***ed. Civilizational progress is moving exponentially. Eventually human intelligence will merge with artificial intelligence. Death will become a matter of personal choice and money, and the subsequent rate of change will be so unbelievably fast that biological humans won't be able to adapt. This massive paradigm shift will lead us directly to a point called the Technological Singularity, a threshold where we cease to be human in the traditional sense." Kurzweil became so consumed by this thesis that he penned the famous book The Singularity is Near and founded a think tank called Singularity University. He even calculated the exact year this singularity is projected to hit. The second person to do that. Welcome Igor Diakonov, a Russian historian with a major in Oriental Studies. His book was published a few years before Modis or Kurzweil's work ever went public. Diakonov categorized human history into 8 distinct phases, ranging from primitive communal systems all the way to the post-capitalist era, and no, Marxist theory has nothing to do with this one. Once again, when you map his phases, you get a chart with history evolving in a leaping manner towards a point zero. It looked suspiciously like Kurzweil's curve, ending in a similar singularity. In fact, Diakonov explicitly stated this a full decade before Kurzweil popularized the term. There is no doubt that the historical process exhibits signs of a regular exponential acceleration. Plotted on a graph, these phases compose an exponential curve that ultimately implies a transition toward a point, the so-called singularity. So, when does the clock run out? To translate history into a math model, let's next take a look at the work of Alexander Panov, a doctor of sciences in physics and mathematics. First, Panov calculated the specific acceleration coefficient between Diakonov's historical transitions. According to the math, the next major inflection point, the start of a ninth historical phase, was to happen exactly in 1989. It's the exact year the Berlin Wall fell, but it's also extremely close to the collapse of the Soviet Union, a monumental transformation of social, economic, and geopolitical reality for millions of people. Another bold but accurate prediction. Second, Panov noticed that Diakonov's 8 phases could be projected backwards in time, using that exact same mathematical coefficient, stretching all the way back to the dawn of biological life. Once again, it tracked even for a planetary-scale timeline. And once again, we see a wild, vertical acceleration racing toward infinity. Third, Panov also used Diakonov's historical data to calculate the exact calendar date of the singularity event. The result? It landed remarkably close to the date Kurzweil calculated, using Modis's data. Alright, we've shown you a bunch of charts with different scientists from completely unrelated fields with their attempts to decode the ultimate mathematical pattern governing the evolution of life. Wait a minute, can't I just massage any large enough data set to make a pretty curve like that? Let's say I was born weighing 3 kilos. After age 2, my weight gain accelerated at roughly 12% annually. At age 10, I weighed 30 kilos. At 15, I was 52. And by 18, I became a grown man weighing 74 kilograms. So what? Do I just project that trend forever? Sure, I could imagine weighing 103 kilos at age 21, but it's highly unlikely I'll hit 163 kilograms at age 25. And there is zero chance I'll weigh half a ton at 35 and generate my own gravitational pull.
Now back to the Three Stooges.
An absolutely reasonable objection. But finding a consistent pattern in large data sets is much more than that. A scientist at the Russian Academy of Science named Andrei Koroteyev decided to figure out whether or not Kurzweil, Modis, and Panov-Diakonov charts were just this data cooking. Oh, and a fun little fact. Russian academic circles love their singularity studies just as much as the US ones. With a degree in historical sciences, Koroteyev was also adept in mathematical modeling. He ran Kurzweil and Panov's data for an exponential. What he found shocked him. Kurzweil's chart aligned with an exponential function only by 27%. So, the singularity is cancelled? Not quite. The dataset didn't fit an exponential because it was an almost flawless hyperbola, a 99% statistical match. The singularity in the concept of an exponent is a path of infinite acceleration where things just get progressively faster until we lose sense of what's going on. But a hyperbolic curve is different. It's defined by a function k over x. The curve there rushes towards a vertical axis, but can never cross it, because at that exact point, x becomes 0. And as we all learned in school, dividing by 0 breaks the universe. This is Kurzweil's timeline. Time keeps marching forward, and eventually life must hit that axis. An exponential future is infinitely increasing evolution all across the function. A hyperbolous future is that of an infinitely increasing evolution until it crosses the bound and becomes an infinite 0. What's also shocking is that entirely unrelated researchers working in their own time and field had the same idea of a macro-evolution of biological perspective transforming into social progress. We have a Greek physicist who inspired an American computer scientist. Separately, we have a Russian mathematician analyzing the framework of his fellow countryman historian. Diakonov used the term technological singularity a full decade before Kurzweil made it famous, yet they had absolutely no contact with one another. Modis and Panov compiled their canonical milestones and historical transitions using completely different historical records and independent datasets. Yet their seemingly arbitrary choices map perfectly onto a strict mathematical function. This one is Modis Kurzweil's, and this one is Panov's. Their data points aren't just described by the exact same hyperbolic function, they also point to almost identical limits. The 0 day. If you looked closely at the formulas on screen, you might have already seen them. One is 2027, and the other one is 2029. Panov is explicit in his notes. The singularity does not imply a planetary catastrophe. It's only one of the scenarios following a crucial point. History is meant to take a new course. The dates are also not entirely that strict. Kurzweil points toward 2045. Panov spoke of a broader window spanning from 2000 to 2030. In general, singularity lacks a rigid, universally accepted definition. No one can accurately predict how humans living in, say, the year 2050 will look back and define it, or whether it happened at all. Maybe historians of the future will point to a year already in our past, like 2020 because of the global energy transition, or the dawn of artificial intelligence, or the beginning of interplanetary colonization, or the moment where science began conquering human mortality. Maybe. Does life feel normal to you? There is a whole trove of stats, data, theories, and opinions on this subject that we couldn't possibly cram into a single episode. If you want access to exclusive breakdowns, source materials, or want to ask me questions directly, head over to our Patreon and join the community. The deep dive companion pieces for this specific episode are already live on the feed. I want to close this episode with the profound words of historian Igor Diakonov. In application to history, the concept of infinity is devoid of meaning. The subsequent phases of historical development cannot go on accelerating, succeeding one another over years, months, weeks, days, hours, and seconds. If we do not anticipate catastrophe, and one would like to believe that wise Homo sapiens will manage to prevent it, then we must evidently expect the intervention of certain new, as yet unaccounted for, driving forces that will alter these graphs. It would be well if they shifted the curve onto a plateau. It would be ill if the change manifested as a precipitous drop in the line on the graphs from some peak already attained. Let us hope that humanity will soon enter phases of non-progression, or weakly progressive development. Let's certainly hope so. You already know exactly who needs to see this video. Share it with them. Before we log off, a massive thank you to our patrons who fund the operations of our small, independent team. As a reminder, our patrons don't just get early access to exclusive research and our private Discord server. Specific tiers also receive custom physical art prints created by a real artist themed around the subject of each episode. The custom artwork for this Singularity episode is officially finished, and it's easily one of my personal favorites. Come join the community, and thank you for watching. See you in the next investigation. And I'm the researcher.